is Sebastian Sierra. Before explaining the operation of the simulator, I will provide feedback of the concepts that should be taken into account for the develop of the practice exercise. The first, magnetic field. A magnetic field is a region of the space where there is a magnetic force acting of the moving shared particles is a physical property associated with magnetic fields is a generation by both electric current and the motion of the shared particle, such as electrons. The unit of the measurement is to Newton on coulombs, represented by N for newtons and C for coulombs. The second change the shares of the particles of the object. The shares of the particle refers to its fundamental electronic property. It is a measure of the electromagnetic interaction of the particle. The shares can be positive, negative, or neutral. The unit of measuring is 2 coulombs, represented by C. Okay. 3. Acceleration. Acceleration is a physical quantity that represents the rate of the change of the object velocity with respect of the time. In the other words, it is a measure of the how quickly an object's velocity changes. The acceleration can be different direction and can be positive or negative. A positive acceleration indicates that an object is increasing its velocity over time, with a negative acceleration indicates that it's increasing its velocity. The units of measurement is 2 meters on seconds the power 2 for the seconds the power 2. Okay. Force is the force is force. The force is force. In the physics, force is a vector quantity that represents the interactions between 2 objects or the particles. It is the definite is any action capable of the deforming, accelerating, or altering the state of the motion of an object. Okay. Upon interacting the simulator, that is after clicking of the begin button, we can observe 4 values on the top, which are the first one is the mass, the second is the initial velocity, the 3 is the shape of the particle, and the 4 is the force exerted by the magnetic field. The aforementioned data are variables. Yes. Mainly, they can be changed because the visualization in the center of the simulator, we can see the magnetic field under the particles. Magnetic field, this, and the particle this. E along with the is the trajectory to vary for the values change. The trajectory. Okay. On the right side, we can add the calculation performed by the simulator according to the states behind evaluate for the particle. Okay. X, Y, Z. Displaying in the force and the acceleration of the particle. Okay. Thinking about into account, we can give an example. Example, Elisa considered a particle with a a mass 40.70 multiplied by 10 the power negative 26 kilograms. Okay, and the initial velocity, the 4.20 multiplied by 10 the power 7 meters on seconds. And the negative charge, and the 3.20 multiplied by 10 the power negative 19 coulombs. Okay. By paying attention to simulation, we can observe how change or the variety of these parameters such as initial velocity share after the particles' trajectories within the electron field. In the first, this exercise will work with a field strength of 0.340 Newton on coulombs. Okay. We will proceed to corroborate the result with the formulas explained earlier to deduce the problem and determine which formula to use. Okay. At this moment, just okay. Okay. Tools. Okay. In this case, we'll use two formulas: acceleration and the force except on the particle. Okay. The force and the acceleration. But use the second formula for acceleration. Is says okay. The formula for acceleration will be a magnetic field for, multiplied by change on mass multiplied by initial velocity. Okay, and the okay, this percent we percent okay. This. So we turn our calculator and put the formula with formula which will be in parentheses. It's divide. Okay. The magnetic field, the value of the magnetic field in this case is 0.340 on the share, by multiplied by share. In this case is a negative. The particle is when the charge is negative, then the negative 3.20 multiplied by 10 the power negative 90. On the mass, this case is 3.70, multiplied by 10, the power negative 26 kilograms. Close the parentheses, multiply initial velocity. This case is 4.20 or multiplied by 10, the power 7. The result is minus negative 1.235 multiplied by 10 the power 14. Okay. The change or the same is simulator results. Now the force units will manipulate the mass by the acceleration. This result. We use the calculator then with the probability of obtaining the accelerated result and multiply by the mass, which in this case 4 multiply by the force is acceleration multiplied by mass. Test them. Okay. That's the mass. The mass in this case is 3.70 multiplied by 10, negative 26 kilograms. Right? The result is negative 4.56 multiplied by 10, the power negative 12. The same or similar result on the simulator. Okay. With this, we demonstrate the functionality of the simulator and the behavior of the charged particle within a magnetic field. Thanks you for your attention. Thanks.